All right, let's take a look at this SAT problem. We have x squared minus 34x plus c equals 0. That is a quadratic. We have a x squared there. 2 is the highest exponent, second degree, polynomial. Could be a parabola or quadratic. Okay, it says in the given equation, c is a constant. The equation has no real solutions. If c is greater than n, what is the least possible value of n? Okay, so we have a quadratic. When we talk about the types of solutions, 2 real solutions, 1 real solution, no real solutions, we are talking about the discriminant. Okay, the b squared minus 4ac. Okay, this is the part that's underneath the radical of the quadratic formula. Remember, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. We use that to solve quadratics when you can't factor it. Okay, so the discriminant, if that is greater than 0, you have 2 real solutions. When it's equal to 0, you have 1 real solution. And when it's less than 0, you have no real solutions. Okay. Now, what's that look like on the graph? Let's take a look. So if I have my graph here, now notice it's equal to 0, so we're trying to find values of x that cause that equation to equal 0. Okay, your result is basically your y value of that. Okay, so when your y value is 0, you have a x-intercept. Okay, so 2 real solutions will look like this. Okay, you have 2 x-intercepts. Those are the solutions. Okay, we have 1 real solution. It would just be the vertex that hits the x-axis there. That'd be the only x-intercept you have at the vertex. Okay, and when you have no real solutions, you're not, intersecting the x-axis at all. Okay, so something like this, where it's no x-intercepts, we have no real solutions. Okay. All right, so use our b squared minus 4ac. No real solutions. That is less than 0. Okay, so remember we're dealing with ax squared plus bx plus c. Okay, so in this case our a is 1, our b is negative 34, and our c is c. All right, so we do b squared, so negative 34 squared minus 4 times our a, which is 1, times our c, which is c, less than 0. Negative 34 squared is 1156. Okay, minus 4c, less than 0. Subtract 1156 from both sides. Okay, divide both sides by negative 4. We get 289. Now, since I divided by a negative, the rules of inequalities tells you that you need to change the direction of the inequality. So it's going to be c is greater than 289. Okay. Right, and that is our answer. C is greater than 289. That means our least possible value for the n, the number that's on the right side here, will be 289. Now, can we do that in Desmos? For the most part. We do have a big number here, 289, so that might make it a little difficult in Desmos. Okay, so we have our graph here. Currently we have 2 x-intercepts, so 2 solutions. Okay, so let's say I start it's opening upward, so I want the vertex, to be above the x-axis. So right now it's way down there. So I'll go to 10. 10 is not enough. And then if you didn't know it was 289, you might go up by 50 or so and move it up, and still not enough. I go to 100. It's still not enough. Okay, so you keep on playing with that. Since I know it was, 289, keep moving this up until it gets to the x-axis. Okay. We see right here at 289, it's right on the x-axis. Anything more than 289, I won't have a solution. So if I had 29.1, okay, that's going to be slightly above the x-axis and no solution. So as long as C is greater than 289, we have no real solutions. All right, so remember, the quadratic, talking about, two real solutions, one real solution, no real solutions, you got to use the discriminant. All right, so hopefully now you know how to solve this type of problem. Thanks.